Hi everyone, welcome. I'm going to do a video now for two problems, and on Tuesday in class we are going to solve more problems. So this video gives you the ability to be able to work ahead of time and be able to prepare before coming to class. So it's a short video for less than 10 minutes. So let's look at the problem. We have to determine the internal energy. We have to determine the internal energy. So this is U, which is the internal energy of a compressed liquid. So this, and of a compressed liquid water. So this is the substance, and this is actually the property. I want you to always look at a problem from property, substance, and the quantity. We are talking about the internal energy. At 5 megapascal, so this is still the property. Now we need to determine the internal energy, which is U, using data from compressed liquid table and B, saturated liquid data, and of course, what is the error involved in the second case? So what is the error involved in the second case? And of course, the second case we are talking about saturation from table. And the first thing you want to look at, we talk about solution. We talk about the steps. So let us talk about step one. Step one. The first thing I said you must do is to read the problem carefully. Read the problem. Carefully. Read the problem carefully. And the second thing you must do, this is step one. So now we talk about step two. We have to select the correct property table. And of course, I said there are two indicators you must use. You must think of the substance. In this case, we have compressed liquid water. We have compressed liquid water. And we must think of the property. In this case, we have what? We have temperature at 80 degrees Celsius and pressure at 5 megapascal. Now we look at a property table that is going to have temperature in degrees Celsius and pressure in megapascal. And that, if you look carefully, you can see that we are going to use table A7. So look at table A7. Look at table A7. Look at table A7. We have temperature in degrees Celsius. We have pressure in Pascal. So these are the two indicators. For us to see that, we're going to use table A7 because we have the temperature measure in degrees Celsius and the pressure measure in megapascal, and of course it's 5 megapascal. Now we've actually known how to choose the right table. Now we have to use data from the compressed table, and in that case, data from the compressed table, I'm just using this is a figure, and this is a figure. It's a figure, and this is a table. Therefore, when the question says data from the compressed liquid table, we have to use table A7. So question A, we use table A7. It's actually what we call from compressed liquid table. And in that table we are given that P, which is 5 megapascal, and T is equal to 80 degrees Celsius, and the internal energy now from those 2 points. That is the pressure in megapascal, the temperature must be 80, and this U is actually the internal energy. So we are looking for this U. So this is the value for U. It's 333.82. So it is actually U 333.82, and the unit is what? Kilojoules per kilogram. Please always write the unit. If you don't write the unit, you are going to fail completely. And B, which we'll talk about from the saturated table. From saturated table, we're going to look for table which talks about saturation. So saturation table is going to be table A4. Let's look at table A4. Table A4 will talk about the saturated water. So this is table A4, and in that table A4 we can get for saturated, we can get the internal energy. We can get the internal energy for internal energy of saturated water. You can see this is saturated water, and this is the internal energy of water. So this is the internal energy for water. So this is the internal energy for saturated water, and so therefore UF is equals to what? Internal energy for saturated internal energy for saturated water. Let me write it very well so you can see. Internal energy for saturated water. And if you look carefully, we are looking at a temperature of the same temperature of what? Temperature of what? 80 degrees Celsius. So this is 80 degrees Celsius, that's the temperature, and we're looking for this value. And that value, I'll draw my line, and this is the value I have. I have UF equal to what? 4.97 kilojoules per kilogram. So therefore, for B, I'm going to have UF at 80 degrees Celsius equals to what? 4.97 kilojoules per kilogram. And therefore, the percentage error, therefore, the error involved now, the error involved is going to be what? It's going to be the value for internal energy for saturation, the value for internal energy for saturation, which is 4.97 minus the value for internal energy for compressed liquid, which is 3.82 divided by the value for internal energy for saturated liquid, which is 4.97 times 100. This is going to give us what? 0.34%. So this expression can be written as what? Internal energy for fluid, which is the saturated fluid, internal energy for compressed liquid over internal energy for saturated liquid times 100 times 100. That is actually how we determine the percentage error. It is done like that because when the fluid has undergone saturation, there is a loss of fluid. There's a loss of energy. There's a loss of energy due to vaporization, and that vapor is actually a loss product. And we could get that by looking at the difference for internal energy for evaporation for saturated liquid, because saturated liquid has a high heat context or a high heat index, minus the internal energy for compressed liquid, which is having a low internal energy, over the internal energy for saturation times 100. So this is internal energy for saturation, for compression. So the error difference now is this internal energy for saturation minus the internal energy for compressed liquid over the internal energy for saturation liquid times 100. So that's how we determine the percentage error. So please look at that carefully and ask question if you have any doubt. Thank you so much. God bless you. Thank you.